hopefully again is review for all of us. Okay. We looked at a couple of different methods. And then today we're gonna look at the last few. Do I have anyone that was not here yesterday to get the handout? Alright, so remember that the first thing that we talked about, which is the little bubble at the top of your handout, is to always look for your greatest common factor. So on our first example, we factored out a 2x. On our second example, we factored out a -4. And on our last one, we factored out an x minus 2. Basically, we were just looking at what we had left and making sure that whatever we had left, remember, is prime, which is, remember that it means it cannot be factored. And then I believe we ended here rather abruptly. Okay, so remember that once I factor out my greatest common factor, which is a 3 in this case, here we're left with 1 minus 4x squared, which is a binomial. And when we have binomials, we also have two additional formulas that we can use. Sum and difference of cubes or difference of squares. So in this case, my 1 and my 4x squared are all perfect squares, okay, because something multiplied by itself equals that. All right. So then if you look in the first bubble on your two terms, it gives you your formula. So I'm just looking at what multiplies together to give me this first one, which is 1. So I'm just going to write a 1 and a 1. And then what multiplies together to give me my second one, which is just going to be that 2x. And then our first, or one of our parentheses gets a subtraction, and one of our parentheses gets an addition. Yes? Do you vaguely remember difference of squares? Okay. Alright, so continuing on, we have some more difference of squares. So again, looking at this first one, I have subtraction, and what do we notice about both of my terms? Squares, right? So especially if they have squares on them already, it's usually a good indicator that we're going to use difference of squares. So what multiplied together is going to give me x plus 2 squared? It's not a trick question. What? Yeah, x plus 2 times x plus 2. And then what multiplied together gives me y squared. Y and y. So that means that my first part that we're going to write is going to be x plus 2, okay, on both of my parentheses. And then my second part that we're going to write is our y. And then remember that one of our parentheses has to have a subtraction sign, and one of them has to have an addition sign. And if we could simplify anything there, we would, okay? But notice that we don't have any like terms, like x and y can't be combined, and then 2 is the only number. But like if for some reason we have like an x and a 2x, you would want to simplify those once you separate the two versions. Now, the next one is a little misleading. Because do we have a squared on that one? No. No. But what do we have? A fourth, right? So can you write something to the 4th power as like something times itself? Yes. So in this case, x to the 4th would be what times what? Like how would I get a 4 there? X squared times x squared. Yes? Are we all good with that? So even though I don't have a square this time, right? It's kind of like a hidden square with that 4 there. Okay? And then what is going to multiply together to give me 16? 4 So I'm going to have 4x squared, okay? And then what's going to multiply together to give me 81? 9. And then again, 4x squared and a 9. One of them needs addition and one of them needs a subtraction. Yes? Now, do we notice anything about either one of those parentheses? They both have 4x squared. What's special about 4x squared? Yeah, it's not prime. We can factor it again, right? So 4x squared and 9 are also what? Perfect squares. So on that first parentheses, we can use our difference of squares formula again. So what's going to multiply together to give me 4x squared? 2x, and then what's going to multiply together to give me 9? 3. And again, remember we need one with addition and one with subtraction. Now, can I use my difference of squares formula on my second one?
Yes.
I see a no. Why?
Because the line is positive.
Because the line is positive, right? Because it's a difference of squares, and difference means subtraction, right? Do I have subtraction in that second one? No, we have addition, so that one cannot be factored any further, so we would just leave that one as it is. Questions on either one of those? Okay. Some people still writing away. Alright. Okay, next up we have trinomials, which we talked about a little bit already. For our trinomials, remember that if our leading coefficient is 1, okay, remember that we're looking for what multiplies together to give me my c value. So remember that our general form of a quadratic specifically is ax squared plus bx plus c. So I want to look at what multiplies together to give me my c value, which in this case is 15. That also adds together to give me my b value, which in this case is 8. So we can start by, if you don't just like see it automatically, which again, the more you do them, the better that you get at them. But you can always just look at the factors of that top one. So like I'm looking at 1 and 15. 2 doesn't go into it. I have 3 and 5. 4 doesn't go into it. So then I have 5 and 3. That's it. Okay. So which combination of those two is going to multiply together to give me 15, but add together to give me 8? The 3 and the 5. Okay, and because my leading coefficient is 1, those are just my two numbers. So I get x plus 3 times x plus 5. Yay, we're done. We like those. The tough thing, though, is on that second example, what's different about it? Yeah, so we have a 3 now as a leading coefficient. So our first thing we want to check for, which again, remember, what's our bubble say at the top? Check for the what? GCF, right? So if we can factor the 3 out, that would be really nice, okay? But in this case, it doesn't, okay? So we do have a leading coefficient that is not 1. So we're going to have to do something a little bit different. And I think your paper calls it the rainbow method. I call it the AC method. It's very similar to what we did here on this first one. It's just instead of just writing our C value on the top part, we have to do A times C, which is why I call it the AC method. So in this case, A times C is going to be what?
18. No,
negative 18, right? So the setup though is still the same. I'm looking at what multiplies together to give me that negative 18. That adds together to give me a negative 7. So the setup part is pretty simple. So again, we can go through our factors of 18. What do we think? 2 and negative 9. Okay, but then this part is a little bit different than what we did up here. Okay, so notice that I can't just put a negative 2 and a negative 9, or sorry, a negative 9 and a 2 like I did on my first one, because then x and x will not multiply to give me 3x squared. Agreed? So what we're going to do is notice that if I add an x to all of these on this second row, okay, we can use the negative 9 and the 2 to break apart our negative 7, which is what we're going to do. So we're going to take the two numbers that we just found and use that to split apart our b value. Yes? Do we all see where I got that from? Yeah? Okay. Then we're going to factor by grouping. Okay, so if we don't remember that, remember I'm going to take my first two and group them together, and my second two and group them together. And then we're kind of treating each group as its own thing, okay? We're going to factor out the GCF from our first group. So what is the greatest common factor of our first two? Almost. 3x. And so then we're left with an x minus 3. What is the GCF of my second group? A positive 2. Okay, you do want to put the sign there because it is going to help us in a second. So it is positive. And we are also left with x minus 3. Well, notice that this is like similar to one of the first examples that we did with our GCF. So when I have two things like an x minus 2 in both of these, I can factor that out to the front. So now we have an x minus 3 in both of these. So we're going to factor that out to the front. So I'm going to factor out my x minus 3. And then we're going to write what we have left over, which in this case would be a 3x and a 2. Now, is that the only way that we can factor quadratic trinomials? No. There's also like the box method. There's just guessing and checking. Some people would prefer to do that. As long as you're using a valid method, I don't care what method you use on your homework, but just so you know, like, this is the method. Like that's the method. I'm going to use the rainbow or the AC method in class. So like for example, just because I think it's the most straightforward and it's pretty helpful because it always works. Whereas some of the other methods only work sometimes. But again, on your homework, as long as you're using some sort of method, I don't care which method you use. Questions, concerns, comments about that? Alright. Alright, here we have x cubed minus 27. How many terms do we have here? 2. Okay, so what do we want to check for first? A GCF. So, do we have a GCF in this case? Do they have anything in common? No. So, we can't factor out a GCF. Okay. Now, so since we have 2, again, we want to go to that 2 terms list. We have a difference. Can we use our difference of squares this time? No, because I have a 3, and I can't write 3 as something squared like I could with the 4. However, what other formula do we have there? In the next bubble. Difference of cubes, right? Which, if we notice, x cubed can be written as x times x times x. And 27 can be written as 3 times 3 times 3, right? So both of those are perfect cubes. and then we're just using our formula there, okay? So if we don't know that formula, to me, the easiest way to remember it, okay, is we have a squared, a b squared, okay? And then, so that's for both addition and subtraction of cubes. Like that pattern is the same. Then the only difference is your addition and subtraction. So your first one is going to have the same sign as my original. The second one is going to have the opposite sign as my original. And then the last one is always positive. So you have soap. Active? Yeah. Alright.
So
Oh, yeah.
So in this case, my A is going to be my X, and my B is going to be my 3. So we have A, B, and then A squared is going to be X squared. A, so X, B, 3, B squared. So 9, or it'll be 9. And then again, it's the same sign as my original, the opposite sign of my original, and always positive. And then we just want to clean it up a bit. So I have X squared plus, I'm going to rewrite this as 3X, and then simplify to give me a 9. Now, the nice thing about your cubed formula is if you use it correctly, okay, your resulting trinomial will not factor. Okay, so you don't have to test it to see if it does factor. It doesn't. As long as you use the formula correctly, that second one is not going to factor. Okay. Questions on that? And then the addition is very similar. So like if this was x cubed plus 27, the only thing that would change is that this would be, my first one would be positive, this would be negative, and the last one would still be positive. Sorry. Questions on that? Alright, we're going to go ahead and skip on. I did want to do one last example with grouping, okay? So we looked at one where we broke it apart, okay? But sometimes if I have anytime that I have more than 3 terms, okay, the only method that is going to work is factoring by grouping, okay? And basically it's very similar to what we did when we broke apart that middle term. I'm going to create groups using parentheses. The only difference is this time I'm just going to create them with whatever I have. Does that make sense? So notice that we're looking to group things together that have stuff in common, okay? So notice right now I can group these first 2 together, and I can try and group the second 2 together. So what do my first 2 have in common? An X, and then what are we left with? An X minus Y, okay? And then what does my second group have in common? 2, and what are we also left with? An X minus Y. So now, what do those 2 terms have in common? X minus Y, and we're left with an X plus 2. So the only difference between factoring by grouping and then like the AC method is that we just start with the grouping instead of having to break it apart first. Questions, concerns, comments on any of that?
Okay, so
Question?
okay, when we're trying to like make sure I'm trying to remember. So you press the breakdown to like what's similar, right?
Yeah, so like if for some reason, let's say my first 2 don't have anything in common, you might need to rearrange them so that they're by something that does have something in common. In this case, they already were, so we could already factor something else. Other questions?